So in day one, we were simplifying radicals, which meant we don't want to have any square roots left under the radical sign. Perfect squares or perfect cubes or anything perfect does not need to stay in jail. It doesn't need to stay in the radical sign. So today we're adding to that. We're going to be simplifying our radicals, and then we are going to be combining like terms, basically. And when I say like terms here, to be like terms, they're going to have the same index and same radicand. So they both have to be square roots, and they both have to have the number inside the same. So, for example, if I had the square root of 2 plus 4 square roots of 2, well, that's 1 square root of 2 plus 4 of them. That's 5 square roots of 2. They're like terms, just like when you had 1x plus 4x is 5x. 1/5 plus 4/5. If you had fractions, same thing. Because if I had the square root of 3 plus the square root of 2, those cannot combine. They're not like terms. So first off, we look, are they like terms? No, they're not. But these can be simplified. So I look at 27 and 12, and I should note that 27 is really 9 times 3, right? So I can write that as 9 times 3, which is actually the square root of 9 times the square root of 3, minus 2, and then 12 can be 4 and 3, so the square root of 4 and the square root of 3. The square root of 9 is 3, and 3 times 3 is 9, square roots of 3. The square root of 4 is 2. 2 times 2 is 4. Square roots of 3. Now I have like terms. I have 9 of these things minus 4 of these things, so I have 5 of those things. Number 2 has cube roots. So remember, I'm looking for perfect cubes. So if you wanted to pull up the notes from before and look through your list of perfect cubes, 54 is really 27 times 2. So I could write that as the cube root of 27 and the cube root of 2. Notice this one is as simple as it can get. So that's just 2 cube roots of 2. And negative 16. Ooh, that would have a negative 8 in it. Negative 8 times 2. And a hint here, when you start simplifying, and you notice that you have one of them that has a cube root of 2, I'd start thinking that maybe each of these other ones could be broken down into 2 times something else. 2 times 27. 2 times negative 8. That way I'm going to end up with like terms in the end. The cube root of 27 is 3. 3 times 3 is 9. This one I couldn't simplify. It's already simplified. The cube root of negative 8 is a negative 2. Negative 2 times 7 is negative 14. And now I'm just combining like terms. So I'm just going to add and subtract the coefficients. So I have a 9 minus 2 is 7. 7 minus 14 is a negative 7. What about a fourth root? Okay, so I'm looking at that and I see the 3. So maybe I try dividing 48 by 3. Well, 48 divided by 3 ends up giving me 16. And notice I can't do anything to the middle one. 72 divided by 3, let's see, I'm going to come off to the side here. 72 and 3. 72 divided by 3 is 24. Now that's not a perfect square. Oh. Okay, so let me break down 24. Well, that's 8 times 3. So 8 is a perfect cube. That's 2 times 2 times 2. So I could rewrite this as Oh, perfect cube. See, oh, I missed that, didn't I? That's a 3. Notice these were both 4th roots. That's a 3rd root. So I'm going to be careful here. Cube root of 8. And then there was the 3 and the 3 that I can't use, so that makes a 9. The 4th root of 16 is 2. Times 7 is 14. The cube root of 8 is 2. 2 times 3 is 6. Now notice these two are like terms, but that one is not. So I can't combine that with the other two. I can add those together. 14 minus 2 is 12. But this one just has to tag along for the right. It was not like terms. Try this one. Four times 7 is 28. Ooh, 56. So let me start with the divided by 8. Okay, that works. 56 is 8 times 7, so if I do a cube root of a negative 8 and a cube root of a 7, that's going to work. 120, 75. I think that's divisible by 25. And I get a 7. The square root of 4 is 2. So 2 times 10 is 20. Cube root of negative 8 is negative 2. Square root of 25 is 5. So notice on this one, the only like terms are here and here. These are square roots. That's a cube root. And these are going to cancel out. Now to some examples with variables in them. Remember, if I'm looking at the exponents, I want powers that are divisible by 2. First off, let me work with this 98, because 98's ugly. 98 divisible by 2 is 49. Cool. That's the square root of 49 times the square root of 2. And these are both going to break down. I know they are, because they're even. The square root of 49 is 7. The square root of x to the 4th is going to be x squared. The square root of y squared is just going to be a y. And then the square root of 2 is still in jail. Now, we have to be super careful on this one. We're looking for like terms. So the radicals are alike, the y's are the same, the x squareds are the same. So I'm just going to add, subtract the coefficients. So 7 minus 3 is 4. And everything else comes along. Negative 40. That can be a negative 8 times a 5. Then I want to break this down into multiples of 6. So a to the 6th and another a. Cube root of, okay, I see that 135. So I know it's divisible by 5. So I'm going to see what happens. 135 divided by 5, I get 27, which is a perfect cube. Cool. Now a to the 4th, I'm going to break that up into a cubed and another a. Oh, I'm running out of room. Cube root of negative 8 is negative 2. Cube root of a to the 6, I forgot my cubes there, is going to be a squared. What's left under the cube root is a 5 and another extra a. Over here, The cube root of 27 is 3. 3 times 2 is 6. Cube root of a cubed is a. A times a squared is a cubed. And what's left under is a 5 and an a. 5 and an a. Well, those are like, oh, they're not like terms. Notice this one has an a squared and an a cubed. I cannot combine those. Now for the product rule. The product rule says if I'm multiplying two radicals and the indexes are the same, just like I could break them apart, I can put them back together. So, the square root of 27 times 5. So I would take 27 times 5 and get 135. Or I can get a little creative here. I'm going to show you an alternative. So this would be the square root of 135, and then I would have to spend time breaking that down. Well, I already know 27 has a 9 and a 3. So I'm going to split that up into a 9 times 3, and then we have this times 5 at the end. The square root of 9 is a 3, and then I'll have a 15 left under. Shortcut. Okay, multiplying these, notice we have some numbers in front. So since they're not in jail, I'm going to multiply those two together. They can hang out. And then I'm going to have 10 times 18. So I think this might be a good idea to break some stuff down. 2 times 5 times 2 times 9. Okay, so I have a square root of 9, which is a 3. I'm going to show this one in detail. So I'm going to take out a 3. Then notice I have a pair of 2's. 2 times 2 would have been a 4, so this comes out as a 2. And the poor 5 gets left under by himself. And I get negative 36 square root of 5. Cube roots, they match. They have to match for this rule to work. I can multiply the ones on the outside. That's great. And then if it makes it feel better, just break this down. 3 times 3 for 9 times negative 8 times 3. So the cube root of negative 8 is negative 2. And then I have a 3, 3, and a 3. So 3 gets to come out. There's nothing left under. This is negative 60. Now, and you could have multiplied everything together and then started breaking it down, but I find it easier just to start breaking it down now. I mean, you could even, negative 3 times a negative 1 is a positive 3. Whoops. I know my stuff. 64 times 8. I can break that into an 8 and an 8 and a 2 and a 4. You could even do it this way. And then you're just looking for groups of 4, because it's an index of 4. Those are 4 2's. Here's another 4 2's. And there's one little 2 left on the end. So 2 gets to come out, another 2 gets to come out. And one poor little 2 stays under, and end up with 12 fourth roots of 2. I'm going to skip ahead to these examples because I wanted to make sure we went over these. You would do the same with this, just you've got variables involved too. Here, we're distributing. So you're just going to be multiplying, but you have to be careful to remember how to distribute. So that's going to be 5 times the square root of 10 times the square root of 5 is the square root of 50, minus 2 square root of 10 times the square root of 2 is the square root of 20. Then I can break it down from here. This is 25 and 2. And this is 4 times 5. Square root of 25 is 5. Square root of 4 is 2. Now, if these were like terms, I would combine my like terms. But since they're not, I'm just going to leave it. Binomials. Distribute. FOIL. 8 times 3. 8 times negative square root of 10. Now I've got to distribute this negative square root of 10 here. Negative square root of 10 times 3. Then negative square root of 10 times the negative square root of 10. Negative times a negative is positive. 10 times 10 is 100. So I have a 24. These two are like terms. Negative 8 minus 3. And the square root of 100 is actually a 10. So this will turn into a 34, like terms, minus 11 square root of 10. Distribute. Distribute. Simplify. This one's a little different. Notice that it's squared. Remember, that means I'm going to take whatever's in the parentheses times itself. That's what squaring means. Now we just distribute. So notice I'm not talking through the whole thing on these because I want you to get where you're trying them yourself. That's going to be a 5. So I've got 21. Remember, if you get lost, you can come back and check these. So for the ones I kind of skipped, what I want to do is I'm going to take a picture. I'm going to pause this and I'm going to do the other examples and then post it up here so that you can just check your answers. But try the rest of them on your own and just see if you get them right. So here's the ones at the top that we skipped. You can pause it. You can go try them, then come back and check your answers. And then here's the ones at the bottom that I kind of skipped because I ran out of time in the video. Try them. Come back and check your answers.